Alright, scholars, time to continue our Module 5 notes. Today we're going to talk about Module 5, Lesson 16, dealing with attributes of trapezoids. Attributes of trapezoids. Now, trapezoid is a type of shape. I'm sure you've seen it before. If you're not 100% remembering what it looks like, you're about to see quite a few examples. Now, we'll start today's lesson by putting our Roman numeral over here. 16 means we need a 10, plus 5 more for 15, plus 1 more for 16. So there's our Roman numeral 16. Now I'm also going to say that this lesson has a lot of vocabulary. We're moving into a part of geometry where there are a lot of terms you're going to have to remember. Now I want you to look at your notes and have them written here, but I also don't want you to have to write every single thing on this page. So I'm going to say some of the terms we'll be using, you're going to want to look back to Lesson 5-1, 5-2, where we went over a lot of those other terms. But here are the most important ones for today. Okay, we're going to start with number 1. Number 1 is polygon. Polygon. Now, poly is a word root that means many, more than one. Okay, polygon. A polygon is a two-dimensional shape with 3 or more straight sides. So 3 or more, that means triangle would be 3, square, rectangle, pentagons, hexagons, all the way up. You start seeing the bigger ones start having that gon as part of the name. Okay? Now, we're not going to be dealing with all of those. We're not going to deal with all of those. We're jumping over the 3-sided gons, the triangles for right now. We are going to be talking mostly in 5th grade about 4-sided. 4, we use quad. If any of you have ever ridden a 4-wheeled off-road bike, it is usually referred to as a quad, correct? Because it has 4 wheels. We're going to talk mostly in 5th grade about quadrilaterals. Okay? Laterals having to do with sides. Quadrilaterals, and actually let's take that S off. Let's just have it be quadrilateral. Quadrilateral is a 4-sided polygon. A 4-sided polygon. Okay. Now we're going to be talking about some very specific 4-sided polygons. There are lots of them. Rectangles are, squares are, parallelograms are, trapezoids are. There are more. But for right now, again, this lesson focusing mostly on the trapezoids. Okay. When we're dealing with trapezoids, and really with most quadrilaterals, we have to be aware of parallel lines. Okay? Parallel lines. Parallel lines, that should be an N. I'm not sure it's really showing up on the screen very well. Parallel lines, or line segments. In fact, sorry, ladies and gentlemen, the second time I'm doing this, but I'm kind of updating the notes as we go. Let's just focus on the parallel part, because lines can be parallel, segments can be parallel, sides can be parallel. Parallel just means that they run side by side. They never intersect. They never touch. Okay. Now, all of the blue lines on your paper, or at least the blue lines on my paper, they're all parallel. They run side by side. They never touch. Even if I extended this way off my paper and the one underneath way off my... they're never going to touch each other. They never intersect. They're parallel. They run side by side. Sometimes they're close, sometimes they're far, but they never intersect. They never touch. Now we are going to contrast this We're going to look at the differences between that and when sides, when lines, when line segments are consecutive. Okay? When we talk about consecutive sides, consecutive lines, they are next to each other. They're next to each other, and they touch. They're connected. So again, much different than parallel lines. Consecutive lines, they're right next to each other. They're right next to each other. Okay, they're touching. Usually we talk about consecutive lines that make angles, and we will be dealing with that during our class lesson. We'll talk a little bit about it down here as well. Okay. And I think the final one we really need to look at for right up top is congruent. Congruent. Okay? If something is congruent, or rather if two things are congruent, that means they are the same size. Congruent is the fancy geometry way of saying equal. They're equal to each other. Okay? Equal. There we go. Like I said, a lot of vocab, and there's actually going to be some down below, too, while we're looking at our trapezoids. Okay. Now, down here, for letter B, not really a process so much as we're going to do some exploring. We're going to explore a little bit. Okay. The instructions that you see on the lesson we do together in class, they're going to talk about starting with parallel lines, starting with parallel lines, starting with parallel lines. We're going to do the same thing. Now, parallel lines, like I said with the blue lines, they can be horizontal. Okay. They can also be vertical. We're going to draw something like that in a minute. Now, if you notice these parallel lines, they're pretty close in length, but they're not exactly the same. This one on the bottom is a little bit longer. If I connect them like this and like this line and this line are consecutive. This line and this line are consecutive. And they make a right angle. Okay. Now hopefully you remember a right angle is 90 degrees if you're using a protractor. And there will be a paper copy of a protractor you can print and use included with this activity on Google Classroom. But if for some reason you need to get one at home or anything, you can always use a plastic one. 90 degrees is the measure of this angle. It's a right angle. Okay. Now, I could do things a little differently too. What if instead I put the longer one on top, the short one on the bottom, but it doesn't really line up this time? When I connect them like that, there are no right angles. We've got this angle right here, which looks pretty big. This angle we call an obtuse angle. And you probably talked about some of this stuff in 4th grade, probably with triangles. This obtuse angle is more than 90 degrees. And if we look up here, we've got a smaller angle. This is called an acute angle. Oh, it's cute. An acute angle. Oh. An acute angle is less than 90 degrees. Now, we're talking about this because, again, when you are drawing these in your book during the lesson, it's going to give you specific instructions. Include a right angle, include an acute angle, include two obtuse angles, include... Okay? So you're going to need to be aware of this. What makes a right angle? It's a corner. It's a box. It's exactly 90 degrees. What makes something acute? Well, it's smaller than the box. Imagine if instead of using lines on the paper, I was using pencils. Okay, this is a right angle. Can you see where the box would go right there? In fact, let's just take the paper away for a moment. Okay, here's a right angle. Now, if we kind of imagine this as a pivot point, this is where it's going to be turning around right here, hands on a clock maybe, we can go ahead. This is smaller, so this is an acute angle. It's less than 90. If I open it back up, there's 90. And if I keep opening it, more than 90, more than 90, more than 90, more than 90. Now it's obtuse. Okay, right in there. The degrees that I keep talking about, again, just to review, this is the measure of the distance between the two segments, between the two sides. It has to do with circles and all sorts of fun stuff like that you'll talk about more when you get a little bit older. Now, we're not going to do too terribly much more. I am going to draw one more set of parallel lines because I want you to, again, see that these parallel lines can be horizontal, but they can also be drawn vertically. Okay. And actually, let's make sure it's showing up on the screen there. There we are. I'm going to connect this. I'm going to connect this. Now, I'm not using a ruler. If I was using a ruler, it'd probably be a little bit better, but this should be fine. Okay. This is a trapezoid also. The trapezoid is connected between points. These points, which again, if you're not sure what I'm talking about, look back at your vocabulary in lesson 5-1. We can label each point in space. Let's say that's A, this is B. I'm just going to go around in alphabetical order. Here's C, and here's D. Okay. This line right here, we would label this as line segment AB. Now, you're not usually going to write it right on the trapezoid. You would put it over here somewhere, but I want you to see the connection. It's basically saying the path between A and B. So this one, the path from this point to this point, would be the path from B to C. This is line segment BC, or side BC. This is C to D. Now, some of you may be thinking DC. Honestly, that's fine too. I usually keep them in alphabetical order, but honestly, if you wrote line segment DC, that would be just fine. That's not a problem. Same over here if you want to do DA, district attorney, I guess. That's fine. But I'll do AD just to keep it in alphabetical order. Okay. A lot of you may be arguing, but if you're traveling around, it would be D. Again, perfect. Not a problem. All good. Now, aside from recognizing how to label the sides, this is important because you're going to get asked questions. Tell me two consecutive sides in trapezoid ABCD. Okay. Well, we know this is trapezoid ABCD because of the points. To find consecutive sides, we're looking for sides that are next to each other. That are next to each other. All right. Well, AB would be consecutive to AD. They touch each other. They make an angle. They work together. AB and BC would also be consecutive sides. Okay. This would be consecutive to this. BC is consecutive with that also. Consecutive just means what is it connected to? What does it share a point with? Okay. Now this point can also be referred to as a vertex. You'll probably see vertex as well, so be prepared. Vertex. Vertices if you've got more than one. All of this taken together is just a way for us to speak mathematically about these shapes. Now, as we go through, we're going to practice all this, and again, a big emphasis is going to be on looking at these and saying, why are these all the same? because you've probably noticed out of all of the vocabulary I've given you, the only thing I really haven't defined is what makes this a trapezoid. We will be discussing that in class. We're going to work that out together in class. So, for right now, we're all set. We'll stop here. If you have any other questions, as always, please make sure you record them or contact me through email, something like that, and I'll see if I can help you. But for now, we're all set. I will see you in class. Thank you, ladies and gentlemen.